Alright, so we would like to use our new optimizing tool to find the dimensions of a box with volume 8 and minimal surface area. Okay.
Oh, so we're not finding the mins and maxes.
Yeah, so we're looking, in this case, only for a min, right?
Okay.
See that?
Okay. Yeah.
I don't care what the max is.
Maxes.
The max is probably weird. We'll actually happen across it anyway, but... Alright, so let's see.
Right, the volume.
Okay, volume. So 8 is
Length times width times height.
cool. Length times width times height. Okay. Oops, box. Which one's which? That one's height.
Yeah. Just put width in the front.
Okay. Which one's the front?
Right there.
Yeah.
Okay, whatever. Label sides.
Okay. And then surface area.
It's a box.
Okay. And then surface area. So I've got this. This thing's like the constraint equation, right?
Mm-hmm.
And then there's surface area.
Yeah.
Surface area is going to be a function of
4LH.
No.
So it's going to be a
Like
function
LW.
of H, L, and W.
okay. It's going to be a function of H, L, and W, right? All three variables. And for some reason we put the height variable first. Whatever.
And then we have to account for all the faces.
Okay, so I need all the faces. So
There's two.
2HL.
Yeah.
so there's two HLs,
Two WLs.
two WLs, and
2WH.
two WHs. Okay, cool. Alright, so how would you do this in Calc 1 land?
Get them.
Isolate one variable and say put H equal to L.
Yeah, okay, we'd solve for one variable in terms of the others, right? We'd make a substitution and then we'd take a derivative, right? Okay, so that's exactly the same thing we're going to do here, right?
Partial.
We're going to say, okay, what does this constraint equation tell me? Which variable do you want to have rid of?
H.
W.
Good answer. I'm going to go with L's because I'm worst at writing L's. I mean, really, does it make any difference at all?
No.
No.
Nah,
You could
pick your
spin this
favorite
around
variable
and
to
it
get
would
rid
be
of.
totally different. It wouldn't matter.
Yeah, right? Like, if you cock your head at it this way and rearrange the variables, it shouldn't matter. Which should inform your thinking that it probably is a cube, right? Okay, so L is 8 over WH. What do I do with that information?
Plug it into your surface area.
Plug it into the surface area. So now I'll have surface area as a function of... As a
W.
function.
W and H.
Yeah, as a function of whatever you're left with, right? And so you'll have, let's see, what do I get on the first one?
2 times W. Oh, yes.
16 over W.
Okay, so I've got 2 times H times 8 over WH. I'm standing right in front of this. Okay, that looks like, cancel some H's. Let's call that 16 over what?
16 over H.
16 over W.
Yeah.
Okay, then there's plus
16 over 8.
16 over H plus
2HW.
2HW. Okay, now what?
Common denominator. Wait.
Now we have a function of 2 variables.
And now we can take partials.
Yeah.
Never mind.
So you could certainly go through the process of finding a common bottom here. I wouldn't particularly bother because then I'm going to have to take partials and then I have to involve the chain rule and the quotient rule in this thing. Probably it's easier if I can just do this as it stands, then I'll only have the chain rule to sort out.
Okay.
So, what's the gradient of surface area? Which derivative are you doing first?
W.
Okay, so you got negative 16 over W squared
Plus
plus 2H. Cool.
And the same thing, negative 16
Negative
over
16
H
over H
plus
squared.
2W.
Plus 2W.
Okay, so that was the partial with respect to W and the partial of surface area with respect to W. And the partial of surface area with respect to H. Okay. Then what do I do with this information? Set it equal to 0. Okay, so I got minus 16 over W squared plus 2H is 0. And minus 16 over H squared plus 2W is 0.
Well, we can solve for either one.
Okay. Hopefully we can solve this, right?
Well, if you multiply,
Things cancel nicely.
yeah.
Okay, so tell me, what do you do?
Solve for H in terms of W with the first one.
Okay, so we're going to take this guy, we're going to subtract 2H from both sides. Okay, so you got negative 16 over W squared is negative 2H. Then what'd you do?
Both sides by negative 2. So,
So
8 over W squared.
H is 8 over W squared. Cool. Then what do you do with that information?
Plug it in for H in that other one.
Okay, cram it into the other one. So then you end up with, so take this, plug it in there, get negative 16 divided by 8 over W squared squared plus 2W is 0. Okay, so minus 16 divided by 64 over W to the 4th plus 2W is 0.
So that's negative 1/4 W to the 4th plus 2W.
Negative 1/4 W to the 4th plus 2W is 0. You guys buy into that? Okay.
And factor out a negative 1/4 W.
Factor out a negative 1/4 W. Okay. So what are you left with?
W cubed.
W cubed minus 8.
8. Yeah, and then so W equals plus or minus 2.
Okay,
Just-
so W is,
Just 2, yeah.
W is 2. You lose one?
Or W is 0.
Or W is 0, right? When W is 0, what's H?
0.
Infinity?
Yeah.
Whoa. Huh?
If you squish a box, the plane gets really, really big.
Yeah, you guys see that? If you make the width 0, right? You got this box and you're smashing it. To keep that volume finite, right? You're going to have to make it infinitely long in one side. What's that going to do to the surface area? Yeah, that's going to make the surface area infinity. There's our max, right? You guys see that? I didn't have a closed and bounded domain to start with, right? I had a continuous function, but not a closed and bounded set. So I wasn't sure that this was going to have a max or a min. Did all see that? In this case, it doesn't have a max, right? Because you can make a box with volume 8 with arbitrarily large surface area just by making it really flat. Does that kind of make sense?
Infinite surface area.
Okay, how about when W is 2? What's H? Also 2? Okay, and then there was one more variable here. Length? And length
8
is
over 2
also 2?
Q.
How do we find H?
Okay, so I took W as 2 and I plugged it back into one of those.
I like
matter
the H
which
was
one.
8
Let me
over
make
W.
sure
Yeah.
that's
Yeah, or this one, or yeah, pick a spot
Do we have
basically.
to clarify what's the minimum surface?
Yeah, so I should have to verify somehow that this is the minimum surface area, right? I lost my gradient vector a while ago.
Well, it's just.
Why would I need that?
Oh, F of WW.
Don't you just plug them back into your surface area equation? To find
You-
out what the surface area is.
Okay, but I don't have edges, right? You guys see that one? So on the other one, I had those hard edges. I could go around and check on each of the edges. Here, I don't have that closed bounded thing. I don't have edges.
Second derivative.
So I could do the second derivative test. Or I could wave my hands at it, right? Like I could write down some jazz and do jazz hands really fast and hope that you don't notice that I'm bullshitting you. That's what hand waving is.
Well, it's like.
You guys have never done this on a math test? Like, where you're supposed to write down write down a reason for something and you're not really sure.
Yeah.
So you write down some math words.
It's the only flat spot we've identified on the entire surface.
Yeah, good answer. Right?
So
This
what-
is the flat spot. It's probably, and definitely, right? If I adjust off of that, the surface area is going to get bigger. You guys see that? Like I have some spatial intuition on this one, so that might be an okay answer. The second derivative test is probably the tool. Let's go check it quick, because we're here.
Does cube have the low surface area?
It does, apparently. Of rectangular prisms, right? Let's see. So what I found was these two, right, were my gradient vector.
Wouldn't that just basically mean every solid that has equal sides has the maximum volume or surface area?
Yeah, the regular GONs are
Yeah.
the best you can do in terms of volume per
Mhm.
surface area. Yeah. Yeah, that's true. All right. Let's actually run the second derivative test, though, because I didn't get a video of running that yesterday. So here I've got my partials. Oops. Partial with respect to H. So I need SAWW times SAHH.
H.
And I need to subtract from that
SAWH squared.
SAWH squared.
Evaluated average.
Yeah, and then I need to remember to evaluate all of these at the critical point. And this is going to be my D, right? That's going to tell me about this concavity. Okay, so I need the bits and pieces of this.
So 32 over WQ.
So SAWW is 32 over WQ.
And the same thing for WHs.
And SAHH is also 32 over H cubed. And SAWH is 2. Right? Okay, so I got, for D, I get 32 over
2 times 2 times 2,
8 times 32 over
8.
8 minus 2 squared.
Yeah, I think we're good.
Okay, so at least it's not a saddle point, right? So I got D is bigger than 0.
Yeah, positive.
Yeah, and then I need to check the concavity, and both of them are positive.
So it's a min.
Oops. So SAWW is greater than 0 means 2, 2, 2 is a min. Cool that? Really, I should maybe also include so this thing, 2, 2, 2, where does that live? Is that a point on the graph, or is that a,
The dimensions of the shape.
yeah, this is a dimension of the shape.
The surface area has
Yeah, we could give the surface area if we wanted to, but scratch that, right? Because they didn't ask me for it, so I'm not going to bother. But I should answer this like a human being.
2 times 2 by 2 or 2.
Yeah, so the man is at
2.
length 2, width 2, height 2. Answered like a human being in speech,
Yeah.
right?
If they're asking for the maximum surface area, what would you do different from the get-go?
Good. If I was looking for a maximum, I would do exactly the same thing. When I got here, I would test it. I would realize that that thing's a minimum, and I would say,
There is
Alright.
no max.
I don't know. There isn't a max,
Okay.
right? I don't have a flat spot that satisfies concave down, right? You don't have a flat spot that satisfies concave down. You're living in this. There isn't a max. Sometimes that happens, right? Like sometimes you didn't constrain enough, or like, why would you want to maximize the
Because that would
surface
be like
area
a
of a
really,
box?
really long, like,
Well, it's like
huge
In
flat
general,
box.
less sides has more surface area for the same volume.
Yes. Yeah, because of course the best you can do for a volume is a sphere, right? Yeah. So, if I was answering the what's the maximum, I would say there isn't one.
I seem to have forgotten why, because W was 0, H goes to infinity.
Oh, why H goes to infinity?
Yeah.
Because if you, where the heck? If you have one of these set equal to 0, right?
Okay.
If you plug in W equals 0, you'll get minus 16 over H squared has to equal 0. The only way that's going to happen is if H is infinity.
Oh, okay, now I see it.
Like 0 is going to cause a division by 0 here, right? So there's some kind of problem. Cool?